today we're going to go over 7.5 first, which is rationalizing denominators. And I'm going to tell you, I'm going to keep it pretty simple because we're only going to hit the rationalization that you would see in a college algebra or even a calculus. If you guys need to go on to business cal or anything like that, you'll see this kind of rationalization. Boom. So first off, what does rationalizing mean? Rationalizing just means you're getting rid of the radical. So look at a basic example, it would be like if we had 5 over the square root of 3. Okay. Now notice there's no equal sign, but we're going to rationalize this thing. So rationalize. We're going to do the denominator first. Denominator. The numerator is already rationalized because it does not have a radical. Okay. A rational number, if you want to go back to like definitions, a rational number is any number you can write as an integer over an integer. So it's like a over b, but a and b are integers. So it's like 2 over 3, 7 over 9. Well, rational numbers will never have a radical after you simplify. Okay. They'll never have a radical. Rational number never has a radical because it's always like just a basic number we think of, like 1/3 or 5 or -2. Those are all rational numbers. Okay. So they won't have a radical. So we're going to come to instances where we have to get rid of the radical either in the numerator or denominator. And to do that, there's just a little trick. And really that's what 7.5 is about. There's a little trick. Now, there's a trick for whenever we have one term in the denominator. And then in a minute, we'll go over if there's 2 terms. Okay. But first, let's look at one term. So if we want to rationalize this denominator because of this radical being down there, all you have to do, and this is a really easy when it's one term. Okay. All you have to do is multiply by whatever the radical is on top and bottom. Okay. Whatever the radical is on top and bottom. That's it. So the numerator, we can't really multiply these together, but we're going to write them together for the notation. So that's the top. But on the bottom, we've got the square root of 3 times the square root of 3. Well, we know since it's the same root, we can multiply underneath. So we wind up with the square root of 9, which is perfect because if we do this correctly, this will always simplify. Okay. So this winds up being 5 square root of 3 over, and we know the square root of 9 is just 3. Ooh, let me put my phone on silent. So notice that final kind of simplification there does not have a radical in the denominator. We have rationalized the denominator now. Okay, there's not a radical down there, and you just need to know it. I know it's gonna be goofy because we won't really use it for the rest of this semester, but we just need to know this, and it's really not hard. Okay, it's really not hard with one term. 2 terms, it becomes a little goofier, but 1 term, it turns out to be just not that big of a deal. Okay, so let's try another one that kind of keeps on simplifying. Let's say we had 4 times the square root of 5 over the square root of 2. Okay, 4 square root of 5 over square root of 2. Now we're still rationalizing the denominator. You've got to pay attention to the instructions because at some point they're going to ask us to rationalize the numerator, and we're just going to flip this. We'll get to that. So rationalize the denominator. Okay, I'm going to multiply the square root of 2 on top and bottom because that's the radical in the denominator. And I wind up with 4 square root of 10 over the square root of 4, right? When you multiply the square root of 5 and the square root of 2, square root of 10, square root of 2, square root of 2, square root of 4. And we know the square root of 4. The square root of 4 is just 2, right? And then what's 4 divided by 2? Oh, that's just 2. So we get 2 square root of 10, okay? 2 square root of 10. So this winds up being our final really simplification. It's not really solution. We're not solving for anything. We're just simplifying, okay? Questions? It's not bad. It really isn't. So if we had like, let's say negative square root of 10 over 2 square root of 5. So negative square root of 10 over 2 square root of 5. So again, look, that 2 is okay to be there. In a way, it's rationalized because 2 is a rational number. The square root of 5 is not rational, okay? So that's what we're going to have to multiply by on top and bottom. Okay, let's see here. So the negative's on the outside. That's fine, right? Negative couldn't be on the inside here. So we get negative square root of 50 over 2 square root of 25, right? 5 times 5, 25, 5 times 10, 50. And now we've got to simplify this thing. Okay, so first off, I'm going to start with the numerator. The 50, I believe, simplifies because it's 5 times 10, then 5 times 2. So I could take a 5 out. This is negative. Remember, the negative's already out there. So negative 5 square root of 2, right? And now look, I'm going to be a little lazy and do this in one step. 25 is just, or square root of 25 is just 5, right? 5 times 2 is 10. Okay, so 2 times the square root of 25. Well, that's just 2 times 5. It's just 10. Now look, this is going to simplify, right? Now look, you're not going to divide the 2 into the 10. That's not even really a 2. It's a square root of 2. It's something weird, like 1.4 or something or another. You only cancel these coefficients. So 5 and 10, oh, that's just 1/2. So when that simplifies, it leaves you with the 2 in the denominator. So you wind up with negative square root of 2 over 2. Negative square root of 2 over 2. Questions, comments, concerns? It's not that bad. It really isn't. This was not bad. It kind of tests your simplifying skills a little bit, but remember that's stuff from last week, right? Not this week. This week's stuff is only this first step, multiplying by the radical on top and bottom. Okay, so let's do one where they change it a little bit and say, well, I want to rationalize the numerator. So rationalize the numerator. Let's see if I can steal one from the book here. Yeah. So let's look. Oh, yeah, because this is presented a little differently. Let's look at number 46. And it asks this question. It says, rationalize the numerator. It's on page 549. And this one's got a square root. Now, the square root goes over everything. So the square root of 3 over 2. Now, remember, if the square root goes over everything, the very first thing you need to do is take the square root to the top and bottom. Okay, that just needs to be the first step. Because maybe one of these has a nice square root. Like if it was a square root of 3 over, 25 or something, we could get some stuff simplified. But this question is a little different, though. It says to rationalize the numerator. So I'm not going to multiply by the square root of 2 on top and bottom. Now I'm going to multiply by the square root of 3 on top and bottom because I want the numerator rationalized. So I get the square root of 9 over the square root of 6. And I know the square root of 9. Square root of 9 is just 3 over the square root of 6. And it's okay that the radical's in the denominator because we're rationalizing the numerator. And we did it. The 3 up top is just a rational number, a boring old rational number. So it is done. Okay? It is done. Okay. So I'm going to give you a few numerator ones for you to try because you've seen the denominator. So let's just do the numerator ones and see what we find out. Let's just do 48. Okay, I'm going to put these up here. I want you to try them. So it's the square root of 12 over the square root of 7. And then let's do one with a variable. I know I haven't done one with a variable, but I think you can kind of logically get to what you have to do. 56, square root of y over 7. Okay, try those two. Now do the numerator. Rationalize the numerator. Okay, let's see what's up. So on the first one, I've got to do what I did up here, right? I've got to take the square root of the 12 or the square root of 7. Now, I'll tell you, at this point, you can simplify the 12 or you can wait till the end. I'm going to just do it at the end because I know at this point, I can multiply by the square root of 12 on top and bottom. Now, it's going to take me a little longer doing this way, but that's just one way to do it. So square root of 12 times the square root of 12 is the square root of 144 over 7 times 12. Is that 84? Okay. Square root of 144 we know is 12. We just kind of said that, right? 12 times 12. But on the bottom, the 84, let's go up here. 84 is what? 42 times 2, 21 times 2, and 7 times 3. Is that right? Okay. So we can take a 2 out, but then we're left with 7 times 3, so 21. And then the 12 and the 2, they simplify, right? 12 divided by 2 leaves me at 6 up top. So this would be 6 square root of 21.
I have a question about that one.
What's up?
I did that a little differently than you just did.
You get the right answer?
Yes, I did.
Yeah, I'm not worried about it, but what'd you do?
I went ahead and simplified the square root of 12 first.
Yeah, that's perfect. So then you did the square root of 3 over the square root of 3, right?
Yeah.
Yeah, and that's
something like that.
Yeah. No, that's perfectly fine, Amanda.
Okay.
Yeah. This section does have a few of those, like, oh, you can work them, 2 or 3 different ways. Okay. Okay, so let's look at 56. 56, oh, now what's kind of nice? It's just a square root of y on top and bottom. So that means all I have to do is multiply by the square root of y on top and bottom. So I get the square root of y squared over. Now, can't really multiply these, so remember we have to kind of smoosh them together. So 7 square root of y. Now the numerator, though, we can simplify. Y squared. Square root of y squared is just y. So it got us to the rationalization of the numerator over 7 square root of y. Boom. Okay. Any questions before I keep going? So now look, guys, this page and the one we just did, it's if we have a single term in the numerator or denominator, okay? Next, we're going to go over what if we have multiple terms, but before we get to that, it turns out it's kind of complex, but it's not that bad. But what students tend to miss are how to simplify fractions with more than just 2 terms. So I'm going to start with simplifying fractions. And so I'm really going to go over kind of the end in a way, because this is what students tend to have the most, or tend to struggle the most with when they wind up really starting these out. And it's going to help us in chapter 8 when we get to chapter 8. Okay, so let me give you an example. If I gave you, or if we wind up with, let's say, 4 over 2x plus 8, okay? 4 over 2x plus 8. This is just simplifying fractions. If you want to, like, it's really a review of simplifying fractions. Now, there's kind of a quick way to do this, but if you do the quick way, which I'm about to go over, you have to realize that, look, there's 3 parts to this fraction, 1, 2, 3. And if you're going to simplify something out of a fraction that has more than 1 term in it, you have to divide the number that you're going to simplify, or the variable, by every single term. It does not work unless you can divide it by every single term, okay? And if we look at this fraction, we've got a 4, a 2, and an 8, right? 4, 2, and 8, and they're all divisible by 2, right? So we can divide all 3 of those parts by 2, and we wind up with 2 over 2 divided by 2 is 1. If you want to write the 1, that's fine. And then 8 divided by 2 is 4. So this winds up being 2 over x plus 4 when we simplify, okay? So the rule is the number or variable has to divide into everything. So if we had another example, I'm just going to tweak this one. And let's say we got 4 over 2x plus 7. Okay, 4 over 2x plus 7. Now, I know your brain is thinking, hey, 4 and 2 simplify, right? But look, because there's 3 terms, there's 3 complete terms in here. And look, now we have 4, 2, looking good so far, oh, and a 7. Look, we can't simplify this. It's done. There's nothing that divides evenly into all 3 of these terms, okay? So this would be considered simplified. This would be considered simplified. Okay? So I'm going to change it up a little bit, and let's throw in some radicals. Let's say we had 3 square root of 7 minus 12 over 15. So 3 square root of 7 minus 12 over 15. So same thing, we're going to simplify this. Now look, we can't add these together, right? Or subtract them, I guess, together, because one doesn't even have radical. Remember, we had to have like radicals to do that. So now we're going to look at the coefficients. The 7, we're not going to worry. It's not even 7, right? Square root of 7 is something weird, 2 point something. Okay? So we've got to look at the coefficient, the integer out there, and the denominator of 15. So 3, 12, 15. Oh, yeah, they're all divisible by 3, right? We can divide all 3 of these by 3. So we're going to do it that way. So 3 divided by 3 is 1. It goes away, right? Really, it's there. It's just a 1. Minus 12 divided by 3, which is 4, over 15 divided by 3, which is just 5, right? Now notice, now if I look at all 3 of these parts, there's nothing that divides evenly into all 3 parts. So we're done, okay? We are done. Nothing divides evenly into all 3 of those parts. Oh, shoot. Okay, so let's do a few more of these just to kind of get in the just goofy things that kind of happen actually in this section. So what if we had let's say 4 square root of 2 minus 6 over 2. So 4 square root of 2 minus 6 over 2. And again, we've got 3 parts here, right? We've got 1, 2, 3. We've got to see if something divides completely into all 3. Oh, and it does, right? We've got a 4, a 6, and a 2. Look, that's, again, I know that you're going, okay, I get it. I heard you the first time. But your brain's going to want to divide 2 divided by 2 for some reason, because we see it. And I know I've probably gone over it in this class, but we are the most gifted of all animals when it comes to pattern recognition. But the issue with pattern recognition is it can mess us up. Okay, we see the pattern of 2 over 2 and we want to divide, but realize this is the square root of 2, right? Again, it's 1.4 or something, it's 92, okay? So we've got to pay attention to the coefficient, the integer out here by itself, and the integer down here. All 3 of those are divisible by 2. So we'd wind up with 2 square root of 2 minus 3 over 1, right? The 2 would go away. So look, 2 square root of 2 minus 3 over 1. Now look, if we divide by 1, we don't have to write that. So this just winds up being 2 square root of 2 minus 3. Okay, 2 square root of 2 minus 3. Okay, questions about this? Something not look right, something look goofy. Okay. So let's just do a few more, and then we'll get to actually what we're going over. But I'm going to tell you, what we're going over is not that hard. The trick isn't that hard. It's going to be the simplifying that we've got to really pay attention to, so we don't get this question wrong. Let's say we had, this happens in this section, yeah. Let's say 5 square root of 10 minus, let's say 15 over negative 5 here. So 5 square root of 10 minus 15 over the square root of 5. Okay, There's a few ways to tackle this, but notice before we even start tackling it, it's going to be 5, 15, and 5, right? They're all divisible by 5. Now, if we do just 5, that's fine. Notice it'll leave us with a -1 in the denominator. So instead of dividing this one by just 5, I'm going to divide it by the -5 down here. So it makes the denominator 1. And we're not doing anything wrong doing it that way. Okay. So I'm going to divide everything by -5 now. So 5 divided by -5 would be a -1 square root of 10. -5 divided by -5 would be a +3. And on the bottom, we'd have a +1 now. Okay. Now I'd write that as negative square root of 10 plus 3. Okay. Negative square root of 10 plus 3. Not a big deal. Okay. And you could even wind up with like 4 terms in the top and bottom. And if you have 4 terms, you've got to make sure that something divides in completely into all 4 terms. So if we had, let's say, 2 square root of x minus 10 square root of y over 8 square root of x plus square root of y, okay? Look, we've got to make sure that if we're going to simplify this, you've got a number that divides into all 4 parts. And it looks like we honestly almost have that, right? We've got a 2, we've got a 10, we've got an 8, but right here we have a 1. So this does not simplify. Even though our brains want it to with 2, 8, and 10, oh my gosh, it's so close, they're all about 2. But look, because we have a 4th term now, whatever we're going to divide has to divide into every single term. And because this 4th term isn't divisible by anything except 1, then it's not simplified. This would be it. Okay, that is simplified. I'll do one that we can't simplify. Let's say we had, I'm trying to find some in here. Yeah, let's say we have like 2x minus 6y over 4 square root of x plus 16 square root of y. Okay. So this one definitely has a number we can divide into all 4 parts now, right? There's 4, 1, 2, 3, 4, right? So we've got a 2, a 6, a 4, and a 16. So we can divide 2 into all of those, right? We can divide 4 into the bottoms, I get that, but we're trying to divide a number into all 4 parts. So I'm going to divide 2 by everything. So 2 divided by 2 is 1, so I'm just going to call that x. 6 divided by 2, that's 3. 4 divided by 2 is 2, so 2 square root of x. And then 16 divided by 2 is 8 square root of y. Okay. And now notice we don't have anything we can divide evenly into all 4 parts. It's a 1, a 3, 2, and an 8, right? So we are done. Okay. Okay. So now let's get to actually the rationalization with more than one term. So if we do this, we're actually going to use a trick with the conjugates. Now, I think I brought up conjugates. Maybe it was this class. It could have been another class. At the end of the very last lecture, we kind of talked about. So a conjugate is if you have a plus b or a minus b, it's going to be the opposite. So a minus b for this one. These are considered conjugates. And what's neat about conjugates is when you multiply them together, the middle terms go away. So if I quickly kind of multiply these together, a times a gives me a squared. First outside would be a times negative b. So I'm going to say it's negative ab. Inside would be b times a. Well, I'm just going to say that's ab. And then lastly, we've got minus b squared, right? And what happens with conjugates, if you multiply them correctly, these middle two are always opposites. So they always cancel. So you wind up with a squared minus b squared, which should look familiar because this is the opposite of factoring difference of squares, right? Remember when we had difference of squares, a squared minus b squared? When you factored it correctly, it was a plus b, a minus b. Kind of neat. Okay, it's the same thing, just backwards. Now, what's nice about this is it will make square roots go away. For example, if we had like 2 plus the square root of 3 and 2 minus the square root of 3, okay, notice these are conjugates of each other. 2 plus and then 2 minus, the same thing. Excuse me. And if we FOIL it out, 2 times 2 gives me the 4. Outside, now we can't really multiply them together, so we're going to smush them together. So we get minus 2 square root of 3. Inside, we get a plus 2 square root of 3. And then lastly, we get a minus square root of 9, right? And notice the middle 2's are opposite. They go away, right? They cancel. So we get 4. Now, square root of 9 is just 3. Now, there's a minus sign there, so be careful. So 4 minus 3, we just wind up with 1. But notice, just like in the first section, how we talked about rationalizing, what happens if you have square roots and you have conjugates, in a way it does rationalize. It winds up being a number without a radical, okay? Pretty neat. And we're going to use that. So let me give you a very, very basic example. Let's say we had 5 over, let's say, I say this is basic. The number ones wind up being kind of harder to simplify than the variables. But let's say we had 5 over 3 plus the square root of 10. 5 over, I know I'm making this up, so it's always interesting when you do this. And now we're going to rationalize denominators, okay? The numerator is already rationalized, right? So the very first thing I'm going to do is put a parentheses around those 2 terms, okay? And I'm going to see if something simplifies. It won't, I don't think, this in this section. But look, if something simplifies, it'll make our numbers a lot easier to deal with. But we got a 5, 3, and the square root of 10. There's nothing we can divide into all 3 of those. So here's what we're going to do. Look, because it's 2 terms, we're not going to multiply by the square root of 10 over the square root of 10. That doesn't get this to go away. If you did that, you distribute to the square root of 10, that turned into 10. But the square root of 10 to 3 would leave you with 3 square root of 10. It doesn't clean up anything. So it doesn't work the same way as the previous examples with 1 term, right? So the way we do this actually is we multiply by the denominator's conjugate. So look, we've got an a plus b going on. We're going to multiply by a, for us is 3, plus, so now we're going to do minus here, the square root of 10, okay? But when you do that in the denominator, because it's a fraction, you have to do it in the numerator, okay? Check this out. Look, we're gonna multiply top and bottom here. Actually, we're gonna leave the top factored. I'm not gonna multiply that 5 through, because if something simplifies, it'll be easier if the 5's on the outside. Well, no, not the way I taught it. Never mind. Let's multiply this 5 through. So we get 15 minus 5 square root of 10 over. Now I'm gonna FOIL it out, but what you're gonna see after a while is you don't have to do the middle 2. You can get a little lazy with these. Efficient is like what we like to say in mathematics. But you only have to multiply the first and the last, because the outside and inside of FOIL will always cancel if these are conjugates. But let's do a few of these before we start getting lazy. 3 times 3 is 9. Outside is going to be minus 3 square root of 10. Inside is going to be plus 3 square root of 10. And then lastly, you get a minus square root of 100, right? Is negative and positive, so negative 10 times 10. Now notice the middle 2 opposites, right? Plus 3 square root of 10, minus 3 square root of 10. This cancels, boom, boom, okay? So in the top, we've got 15 minus 5 square root of 10. Ooh, I forgot the one there. There we go, 10. Over, now we know the square root of 100 is just 10, so 9 minus 10. So we wind up with 15 minus 5 square root of 10 over negative 1. Kind of cool, okay? Now, Excuse me. Now, technically, we have rationalized the denominator. This is a rational number. Okay, -1 is. We just don't leave -1s or 1s in the bottom. So we're going to divide all 3 parts by -1. So 15 divided by -1, that's -15. -5 divided by -1, well, that's just a +5. And then really there's a 1 in the denominator now, so we're done. Okay, a 1 in the denominator, so we're done. Whew. It took a lot of work, but hopefully you kind of seen along the way what we're doing. So really the first step, which is always kind of the doozy, because if we get the first step wrong, we're not going to get to this, okay? So the first step, multiply by the conjugate of the denominator, okay? 3 plus, since it was 3 plus the square root of 10, it's going to be 3 minus the square root of 10. And then just see where it goes. Distribute the top, or sometimes you have to FOIL out the top if there's 2 terms, okay? And then FOIL out the bottom. Middle 2 will always cancel, and then add correctly. You'll always wind up, look, if at this step you don't end up, actually after the first step, if the radicals don't go away in the denominator, we did something wrong, okay? We did something wrong. So let's see here. Let's do that. I'm going to steal one from the book. And I want you to try it just to see if you're on the right track, and of course we'll go over it. So this is number 32 in the book on page 548. We've got 3 over the square root of 7 minus 4. 3 over the square root of 7 minus 4. So I want you to rationalize the denominator. That's what the question states. Rationalize the denominator. Okay, let's see if we got it. Look, this denominator, the square root of 7 plus 4, the conjugate's going to be the square root of 7, I'm sorry, the square root of 7 minus 4. The conjugate's going to be plus 4. Okay? Now we have to multiply that on the top as well. So distributed through the top, we get 3 square root of 7 plus 12. Right? FOIL this out. Square root of 7 times the square root of 7, that's a square root of 49. Outside, we get plus 4 square root of 7. Inside, we get a minus 4 square root of 7. Lastly, I get a minus 16, right? So we wind up with this, which looks crazy, but everything's going to kind of, actually, all the radicals are going to go away in a way. Two of them, these middle two, are opposites, right? 4 squared root of 7 minus 4 squared root of 7. They go away. Boop, boop. They cancel. So on the top, we're left with 3 squared root of 7 plus 12. But on the bottom, the square root of 49 is just 7, right? Minus 16. So we get 3 square root of 7 plus 12. Over 7 minus 16 is a negative 9, right? Now look, because it's negative, I'm going to divide by negative. Everything by negative to get this positive. I need that bottom or that denominator number to be positive. But notice we've got a 3, a 12, and a 9. They're all divisible by 3, right? Now I'm going to do this by negative 3 because I want that negative out of the radical. So I'm going to divide everything by negative 3, and I wind up with negative square root of 7, right? 3 divided by negative 3 is just negative 1. 12 divided by negative 3 would be a negative 4. And then negative 9 divided by negative 3 is a positive 3. Okay? So 2 negatives, which is fine, and then a positive 3 in the denominator. Questions? Questions on Zoom? You guys getting it? Comments, concerns? I'm going to throw up a few more examples, and then we're going to go on to 7-6. We're not probably, I don't think we'll get done with 7-6 today, but we'll start and kind of easier ones. Let's look at, some of these are kind of crazy. Let's look at 36. 36 is looking at me. I can tell this is going to be a lot of work. Oh man, 4 terms, that's crazy. And they're all radicals, that's even crazier. But it's not a big deal, okay? We've got 4 terms going on, all radicals. I'm going to work this one with you. If you want to start working on it, that's fine. See if I can catch up. Notice we've got the square root of 2 and the square root of 3 in the denominator. We're still rationalizing the denominator on 36. So I'm going to multiply everything by the square root of 2 minus the square root of 3, right? The square root of 2 minus the square root of 3. So this is going to take a little more time because I'm going to have to FOIL out the top now, right? Because we got 2 terms. FOIL out the top and bottom. So let's see here. Square root of 3 times the square root of 2, that's a square root of 6. Square root of 3 times the square root of 3, that's this negative because it's positive minus square root of 9. Inside, we end up with plus the square root of 8. And lastly, we end up with minus the square root of 12. Okay, I can tell some of these are simplified, right? That's going to simplify. 8 and 12, I think, also simplifies. We'll get there. Now let's FOIL out the bottom. Again, you don't have to FOIL out this bottom. You can just do the F and L if you want. But first, we've got the square root of 2 times the square root of 2. That's the square root of 4. Outside, we wind up with minus square root of 6. Inside, we end up with a positive square root of 6. So that's what should happen. These should be opposites. And then lastly, we end up with a minus square root of 9. Okay. We're going to go through all of these and see what needs to be simplified. Well, first off, these can't cancel. That's nice. It's nice to get rid of 2. Square root of 6 does not simplify. Okay, it's just 3 times 2. Square root of 9 does simplify. It's a 3. Now 8, I'm going to do this one up here. 8 we know is 2 times 2 times 2, right? So I can take a 2 out. Plus, yeah. 2, now remember there's a 2 left over. So 2 square root of 2. 12, I've got to simplify this one. That's 4 times 3. And then 2 times 2. So I can take a 2 out. And I'm left with a 3. So I get plus 2 square root of 3, right? So square root of 6 is just square root of 6. Square root of 9 is 3, now it's minus. This factors into 2 square root of 2, and or simplifies into 2 square root of 2, and then this simplifies to 2 square root of 3. Now, ooh, you know what? That's a minus sign right there. I got to be careful. That's not my final answer, so it'll be fine. In the denominator, though, the square root of 4 is just 2. And the square root of negative 9 is just 3, so 2 minus 3. Now, I don't want to write all this again, so I'm going to be a little lazy. This winds up being negative 1, right? So I'm going to divide everything in the numerator by negative 1. So I get negative square root of 6 plus 3 minus 2 square root of 2. And then actually this winds up being a positive 2 square root of 3. And we're done. Hey, hey. The crowd goes wild. Okay. Questions? I know I kind of skipped a few steps, like 2 minus 3 is negative 1, and then I just divided negative 1 into everything up there. But at least this kind of gives you the step-by-step stuff going on. Okay, let's do one with variables. I feel like the ones with variables turn out to be a little easier because there's less simplification, typically, because the numbers wind up simplifying more. So let's choose one with variables that looks a little weird. Let's say 42. So 42, same thing. Rationalize the denominator. We've got 2 square root of a over 2 square root of x minus the square root of y. Okay? Put parentheses around here first. So this is what 42 looks like on page 549. Now, again, don't be fooled. Don't cancel the 2's out here because we have a third term. And 2 doesn't divide evenly into everything. So again, we're going to do the same thing we've been doing so far. So we're going to multiply by 2 square root of x plus the square root of y, right? So if this was a minus b, this is going to be a plus b. And whatever we multiplied in that denominator, we have to multiply in the numerator. Okay? And then I've got to distribute through up top. It's only a single term, right? Remember the 2 and the 2. That's 4. And then look, the x and the a. So that's, I guess you can write it as x, which is interesting. Yeah. I don't think I've ever seen an a and an x put together. And then a, now look, 2, remember there's a 1 here. So 2 times 1, that's 2. Square root of a, square root of y, so that's square root of a. Okay. Y, but pronounced a. Anyway, so let's FOIL the denominator out. So we get 4 square root of x times x is x squared. Outside we get plus 2 square root of xy. Inside we get minus 2 square root of xy, right? And then lastly we get minus square root of y squared. Okay. Then let's see what else. Now the middle 2 simplify again, right? They cancel again, I should say. If they don't cancel, you did something wrong. Okay. Either you multiplied wrong or you chose the wrong conjugate. So up top we've got 4 square root of ax plus 2 square root of ay. Now bottom, x squared is just x. So this one's being 4x minus square root of y squared is just y. Okay. So let's think about this. Can we simplify past this? Can we divide something out? No. I feel like Dora the Explorer, right? When you ask a question and no one replies, and then eventually she tells you. Anyway, no, you can't because of the y by itself, right? If the y had a coefficient that was even, we could multiply everything or divide everything by 2, right? But we can't, so we're done. This is simplified. Okay, that's simplified. Okay, so for homework in this section, this is HW, section 7.5. I want you to start on, it's on page 548, and do 1 through wait, I'm going to chop it up. They do cube roots, which is goofy. 1 through 17, you'll never have to find a rationalization of a cube root. 1 through 17, and then we'll do odds. So 21, 23, and then 31 through 49, and then 53 and 55. So I just chopped this up because they go over cube roots, which is kind of crazy. And you can do all odds on this one. Odds. There's no reason to cube root. So that's section 7.5